This is worksheet 2.8. We're graphing absolute value functions or writing the equations of absolute value functions given a graph. Here, before we start doing that, we're just going to analyze where the vertex is and if it opens up or down. So remember, our template or mother function of a absolute value function looks like this. Y equals a times the absolute value of x minus h plus k. And realize that it is important that there's a minus sign here after the x. So if there's not, we want to rewrite that with subtraction actually. So it's like the opposite of adding the opposite, or the opposite of chopping or chop slashing. So let's give this a shot. So here I have, well, there's nothing in front of here, but remember multiplication wise it's a 1, it's a positive 1, times the absolute value of x. Now instead of writing x plus 3, I'm going to actually add the opposite, or unchop chop. And then we have minus 5. So the vertex occurs at h comma k. So what value is in the h position? What value is being subtracted from the x? A negative 3 is being subtracted. See, if we actually do this weird step right here, it tells us what's being subtracted from x. Negative 3 is being subtracted from x, so that's the x value of my vertex. And then my y value is whatever is being added to outside of the absolute value. So that's negative 5. So if we want to make that into a plus sign, we can add the opposite or chop slash that. It's a negative 5. Now it opens up because it is a positive multiplier out in front. So it's going to go up. Next one, let's rewrite it in, well, actually this is already written with subtraction. So let's see here. There is my multiplier out in front. There's my a value, and it's negative, so it's going to open down. My vertex is h comma k. So what's my h value from the mother function? What value is being subtracted from x? 1 is being subtracted from x. What value is being added outside of the parentheses? 6 is. Good. Number 3. Opening up versus opening down is all about whether the multiplier out in front is positive or negative. And this is a fraction, which freaks people out, but it is a positive fraction. So it's going to open up. The vertex is whatever is at whatever is being subtracted from x. 3 is being subtracted from x. And then for the y value, what is being added to outside of the absolute value sign. And that's 7. All right, last one. I'm going to rewrite this one. First of all, because there is something outside of the absolute value bracket, and that's a negative 1. So the absolute value is being multiplied by negative 1. And then I see the plus sign, and I don't want to write this as adding 5. I want to write this as subtracting negative 5, which seems weird, but realize that if we add the opposite, it would be equivalent. So first of all, I'm going to drop down to whether it opens up or down. It's going to open down because it's being multiplied by a negative value. Next, the vertex. So what value is being subtracted from x? Negative 5 is being subtracted from x. So the vertex occurs at negative 5, comma, oh, the next value is supposed to be what's being added to outside of the absolute value bracket. What number is being added to outside of the absolute value bracket? 0. Now we don't write that in the function, but it's really important that we write that coordinate down. Otherwise we'd be like, how high or low do I go as I plot the vertex? All right, so now we're going to use that same skill and really answer the same questions. Where's the vertex and is it opening up or down, to graph these things. So here, the vertex of this first function, I'm going to rewrite it as y equals 1 times x minus negative 1 minus 4. So I just changed this to subtracting negative 1. It means the same thing. And then I just threw the multiplier on out in front. So the vertex occurs at, well, what value is getting subtracted from x? It's negative 1. And what value is being added to on the outside? Negative 4 is being added to this function on the outside of the bracket. So -1, comma -4 is my vertex. And then from there, my slope is whatever the multiplier is as I go to the right. So the slope is +1, which means go up 1 and right 1. Boom, 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 boom. I probably should do dots. Man, this is messy. Boom, 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 boom. And then I don't care how curvy your line is. If you have the dots and I can see them, I know what you meant. I think it's almost faster to do that. Then, for the left arm, we're going to do the opposite slope. So this is the right arm. This is the way it'll always work. You do it as the slope says right there. But for the left, you do opposite. So instead of being a +1, it is a -1 slope. Now you can write that over 1, so you go down 1, right 1 from the vertex. Now this actually shows going down 1, right 1, but when I reverse it, it's up 1, left 1. These green dots have a slope of -1. And both arms here make the absolute value function. That's fun. All right, let's go after the vertex over here. So the vertex is the number that's getting subtracted from x. 1 is getting subtracted from x. And then what is getting added to x outside the absolute value bracket? -2 is getting added to the x. You can chop slash that if you need to. It's definitely a -2 there. So the vertex is at 1, -2. Now the slope of the right arm is 3, which is the same as 3 over 1. So I'm going to go up 3 and right 1, but that's just for the right arm. Up 3, right 1, up 3, right 1. Zing a line. Now, it's supposed to make a V, so you can visualize there's my V right there. And to do that one, you go, you can go down 3 and right 1. That's a slope of -3. Or you could actually, we need to go up 3, but we need to go left 1 to make this look like a V. Up 3, left 1, up 3, left 1. Should have done that in opposite colors. Now I guess this is just going to get kind of weird. There we are. Beautiful. Awesome. Number 7, I noticed that there's not subtraction after the absolute, or after the x in the absolute value sign. So instead of writing +7, I'm going to write -7. Here we go. So the vertex starts with what value is getting subtracted from x. That's -7. And then we ask the k value, or the k or y coordinate of my vertex is whatever's getting added to outside of the absolute value sign. -4 is getting added outside of the absolute value sign. So that's my vertex. -7, -4. Right there. This is my slope. So my slope for my right arm is -2. So I'm going to go down 2, right 1 from the vertex as I go to the right. Down 2, right 1, down 2, right 1. Zinging a line. Now you can see the V, it's an upside down V. It's going to go this way now. So now I need to go down 2, but left 1 for my left arm. See how that's symmetric? Needs to be symmetric. I don't know why I dashed that line. It's solid. There we go. The arms aren't the same length. Oops. Alrighty, so now we're going backwards. Now we're going to write the equation given the graph. So there's two things. We need to identify the vertex and the slope of the right arm. Slope of the right. So the vertex is at 2, 4. So as we build our equation, and I'm going to leave some space right here, we always have in the absolute value x minus whatever the x value is. So the x value of the vertex is 2, so it's going to be x minus 2. And then outside of that, whatever the y value is, that's what's getting added to outside the absolute value bracket. So plus 4. The multiplier out in front is whatever the slope of the right arm is, which it looks like the slope is down 3, right 1. If we're going down and to the right, that is a negative slope. So it's negative 3 over 1, which is really just equivalent to negative 3. In the end, folks, we want our equations written as concisely and cleanly as possible. So negative 3 is the best thing to write. Negative 3 over 1 is not wrong, but this is easier. All right, let's try the next one. The vertex, I'll do a different color here. The vertex is at 4, negative 2. So, as I start writing the equation, I'm going to leave some space for the multiplier. The x value is whatever's getting subtracted from x. So it's x minus 4. And then the y value is whatever's getting added to the outside. So that'd just be a 2. And then for the multiplier, we use the slope of the right arm. And the slope is 2 over 1, which equals 2. The slope of this right arm is a positive slope. It needs to be a positive 2. And there we are. Last one. Find the, oops, yeah, I guess I did the slope right there. Last one. So the vertex is at negative 3 comma 0. And the slope, well, let's start writing it. So I'm going to leave space for the slope, and we'll talk about slope in a second. The x value is whatever is getting subtracted from x. So you know what? I'm going to write this twice. What's getting subtracted from x is negative 3. What is getting subtracted from x is negative 3. And then the y value is whatever is getting added to the outside of the absolute value. And what's getting added to the outside of the absolute value is 0. Technical difficulties, just a second. Might have to freehand this. This is going to get messy. Nope, we're not out of batteries. TMI? Okay. Well, nothing's, thanks for sticking with me here, nothing's getting added to the outside of the absolute value bracket because the y value is nothing. So I'm going to write plus 0 for now. All right, then finally, our slope of the right arm. We're going up 1 and right 3. So the rise is 1 and the run is 3. Now that's a positive slope, by the way, folks. So it's 1/3. So the slope is 1/3. This is a good way to write it, but it's not the best way to write it. The best way to write it is, well, 1/3 has to stay 1/3. But x minus negative 3, when we're finding the vertex, that's when we change addition back to subtracting the opposite. But really here, I want to chop this, so I just write simply x plus positive 3. And then this plus 0, I'm not going to bring down. Don't bring it down, just leave it. Because it's more simple to write it this way. Beautiful.